Good morning, students. Welcome to the world of digital electronics. Today, we are handling an important topic, that is logic gates. Logic gates are the basic building block of any digital system. It is an electronic circuit having one or more than one input and only one output. The relationship between the input and the output is based on a certain logic. The following slides show different logic gates in a digital system. Let us start with logic gates. The first one is NOT gate. The NOT gate is an electronic circuit that produces an inverter version of the input at its output. It is also known as an inverter. That means NOT gate is also called an inverter. If the input of NOT gate is 0, its output is 1. Likewise, the input of NOT gate is 1, its output is 0. It is clearly shown in the truth table. In this PowerPoint, we can see the symbol as well as the truth table of NOT gate. A truth table is a good way to show the function of a logic gate. Otherwise, a truth table that represents the function of a logic gate. In the case of logic gates, 0 means low and 1 means high. Next gate is AND gate. The AND gate is an electronic circuit that give a high output, that is 1, only if all inputs are high. In this slide, the symbol of the AND gate as well as the truth table of the AND gate is shown. This AND gate is a 2-input AND gate. A and B are the 2 inputs of AND gate, and A dot B is the output, or AB is the output. A dot is used to show the AND operation, that is A dot B. Bear in mind that dot is sometimes omitted, that is AB. From this truth table, it is clear that it is a 2-input AND gate where A and B are the 2 inputs of this AND gate and A dot B is the output. In the case of first case, A is 0 and B is 0. That means both the input of the AND gate is low. 0 means low and here 1 means high. Then the first case is A is 0 and B is 0. That means both the input are low. That time the output is also low. That means 0. A dot B is equal to 0. Second case, A is 0 and B is 1. That time the output A dot B is 0. That is low. And the third case A is 1 and B is 0. A dot B is equal to 0. In the last case, both A and B, the 2 inputs of that AND gate is high. That time only the output of the AND gate is high. In this slide, we can see a truth table of AND gate, that is a 2-input AND gate, where A and B are the 2 inputs of AND gate and A dot B is the output. When both A and B are low, that is 0, 0, 0, its output is also 0. That means low. Here 0 means low and 1 means high. And another case, A is 0 and B is 1. A dot B. So, from this truth table, it is clear that it is a 2-input AND gate. Its input are A and B. Its output is A dot B. When both input of the AND gate is 0, its output is also 0. Here 0 represent low and 1 represent high. In the case of one input of the AND gate is low and the other input is high, then also the output of the AND gate is low, that means 0. But in the case of A and B is next gate is OR gate. The OR gate is an electronic circuit that give a high output, that is 1, if one or more of its input are high. A plus sign is used to show OR operation, that is A plus B. In this slide, the symbol of OR gate as well as the truth table of OR gate is shown. It is a 2-input OR gate. From this truth table, the function of OR gate is clear, or OR operation is very clear. A and B are the 2 inputs of OR gate, and A plus B is the output of the OR gate. When both A and B are 0, the output of the OR gate is 0. In the second case, A is 0 and B is 1. Output A plus B is equal to 1. And the third case, A is 1 and B is 0. A plus B is equal to 1. And the last case, that is the fourth case, both A and B are 1. The output A plus B is equal to 1. Here 0 means low and 1 means high. Next gate is NAND gate. NAND gate is equal to an AND gate followed by a NOT gate. In this slide, the symbol of NAND gate as well as the truth table of NAND gate is shown, where A and B are the 2 inputs of NAND gate and .B bar is the output of NAND gate. The outputs of all NAND gates are high if any of the input are low. The symbol is an AND gate with a small circle on the output. The small circle represents inversion. Next gate is NOR gate. NOR gate is an electronic circuit. An OR gate followed by a NOT gate is called a NOR gate. Once again, an OR gate followed by a NOT gate is called a NOR gate. In this slide, symbol and the truth table of NOR gate is shown. The logic NOR gate is the reverse or complementary form of OR gate. Next logic gate is exclusive OR gate. This is an electronic circuit which will give a high output if either but not both of its 2 input are high. The symbol of XOR gate and the truth table of XOR gate is shown in the slide, where A and B are the 2 input of XOR gate and A XOR B is the output. Next logic gate is exclusive NOR. Basically, the exclusive NOR gate is a combination of the exclusive OR gate and the NOT gate. The exclusive NOR gate circuit does the opposite to the XOR gate. It will be a low output if either but not both of its 2 inputs are high. In this slide, the symbol of XNOR gate and the truth table are shown, where A and B are the 2 input of exclusive NOR gate and A excluded B bar is the output of exclusive NOR. Okay. In this section, we discussed about the different logic gates in an electronic circuit or a digital circuit. These logic gates are the basic building block of a digital circuit. So these gates have higher importance in digital electronics.